describing what this entire fuss is about.
Thank you, Shreyan, for the kind introduction. Hi, my name is Soumitra Das. I'm the president of the Climate Initiative. Thank you, everyone, for joining. Good morning, good afternoon, good evening, depending on where you are. Today, I'm going to talk about a very important topic, melting of glaciers, Himalayan glaciers in particular, and how that is affecting and or will affect the billions of people in the planet. Let me share my screen first, and then I can show you my slides. Can you see it? Okay. So first, let me give you a little bit of geographical background, and that would help understand what we are talking about. So here is the map. Can you see the map? Okay. So yes. Himalayan glaciers, when you talk about the Himalayan glaciers, it starts from the east in Myanmar and goes through about 1,500 miles or 2,400 kilometers in Pakistan, Afghanistan, Pakistan border, India-Pakistan border. And then it joins with another mountain range called Hindu Kush Karakoram in Pakistan and Afghanistan. And the whole area is called Hindu Kush Karakoram Himalayan range. And interchangeably we'll use Himalayan and Himalayan range at the same time. It passes through 8 countries, Myanmar, China, Bangladesh, Pakistan, Afghanistan, Nepal, Bhutan. I think I covered all of them. So 8 countries we are talking about. Himalaya means, in Sanskrit, it is abode of snow. It contains about 55,000 glaciers and stores largest amount of snow outside Antarctica and the Arctic. The problem is that it is melting faster than the rest of the world. There are 2 billion people living in that area that depend on food, agriculture, drinking water from the 10 rivers originated from these glaciers. And there are 240 million people that are living in those mountain areas. When it is melting, it is causing problem. The first problem is that the people who are living in the area, they are experiencing this large number of glacial lakes. As the water is retreating, the glacier is retreating, you have large number of glacial lakes is formed, and that is risking the outburst, the flooding situation in the area. And we have seen several glacial lakes outburst flood due of recently, probably last year. On the other side, you see in the downstream a large amount of huge flood that is causing millions and millions of people displaced and making them climate refugees. And Bangladesh is probably one of the worst affected country we have seen because of this flooding. But 10 million people, and think about 10 million people, the size of the whole New York, is climate refugee today. I will give you a short video of what is happening in Bangladesh because of flooding.
In some parts of the world, the effects of inaction are already clear. The slums of Bangladesh's capital are filling up with climate migrants. Minara comes from Bola district, an area in southern Bangladesh. There, like many other parts of the country, rivers swollen by heavier rain and melting Himalayan glaciers are washing away people's homes. Many, like her, have lost everything.
বলার বারে তো জায়গা জমি নিশ্চিত ছিল না, অনেক জায়গা জমি ছিল, অনেক ফসলের জমিন ছিল, বাড়ির জায়গা অনেক ছিল, বাড়িতে অনেক ফলমূল গাছ, বিভিন্ন ধরনের অনেক কিছু ছিল, সবকিছু নিজের গাছের জিনিস মানে খেতে পারতাম। এখন তো আর ওগুলা খাইতে পারে না, ওগুলো তো নাই। নদী টিন ভাঙ্গা দেওয়ার পরে ঢাকা চলে আইতে হয়েছে। বাড়িতে থেকে তো অনেক আরাম ছিলাম, মানে খুবই খারাপ লাগতো, মানে সহ্য করার মতো না। ঘর দুয়ার ভাঙ্গা নিয়ে চলে যাওয়ার মতো টাইম ছিল না।
1.1 to 1.3 degrees of global warming has already transformed Minara's life. It's one of the reasons why so many migrants like her are moving to the city each year. Nearly 400,000, according to the last estimate. And climate models show there could be much worse to come.
So that's the problem we are facing because of the melting today. On the other side of the problem is that when the melting, the IPCC, the recent forecast is that Eastern Himalayas will be dried. There will be no ice, virtually no ice free by 2050. And some other prediction that Central and Eastern Himalayas will disappear by 2035. So think about the situation that 10 rivers, mighty rivers in Asia, are originated from these glaciers, and there will be no water. 2 billion people directly depend on drinking water, agriculture, hydroelectric, everything on this. So their lives and livelihood will be at risk. And then 3 billion people indirectly depend on the agriculture, the food produced in those 10 river basins. The problem is very severe, and this is the message I want to get across. We cannot wait 30 plus years. Now we think about India has, we are saying emission reduction, net zero by 2050. India's saying that, okay, 2070, China, Russia did not even show up during this COP26 meetings. We cannot wait that long. We need immediate intervention. That's the point I want to get. That situation is very bad and it will get worse. So the question is that what can we do at this time? That's the question. So before you understand what is causing the problem, we need to understand that. So one thing is happening, the global temperature, the carbon dioxide accumulation in the atmosphere, causing the temperature high. And in Himalayan cases, the high mountain Asia, it is rising faster than the average. So that's one of the problems that we have. It's a global problem that we have. And the second order problem is that as the melting happens, the albedo of these glaciers goes down, it decreases. So second order problem. So when the albedo goes down, it absorbs more sunlight and accelerates the melting. And the third and the very serious problem we have, and that is one thing I'm going to focus here, is the black carbon glaciers. There's a huge amount of pollution, particularly black carbon, that is in the air, that is depositing on the glaciers, making it black. And because it gets black, it absorbs more sunlight and accelerates melting even further. And recent World Bank report, I thought that in 2021, that this black carbon is one of the key reasons for accelerating the melt, and by 50%. So the solution we are thinking at this time, immediate solution that we are thinking, that we have to reduce these black carbon emissions and increase the albedo of the glaciers. We have discussed decreasing albedo of the glaciers by silica sand. Our Arctic Ice Project is working with us on this. And Leslie is definitely on the call here, who is the inventor of this technology. So we are thinking, we discussed this a couple of times. In this talk, I'm going to focus on the black carbon emissions. Okay, next slide. So black carbon emission, what is black carbon? It comes from incomplete combustion of fossil fuel. What are the sources of this incomplete combustion? One of the major sources in India in this, there are three sources we can think about: cooking, residential, the manufacturing, and the automobiles, the transportation part. But in Indian context, we see that residential, the cooking causes the maximum amount of black carbon pollution. You can see in this chart, 57% is coming from cooking or residential, about 23% coming from manufacturing, primarily brick kilns. So let me tell you how the Indians, a large portion, about 60 to 70% of Indian population, and that means how much? About 700 million people. So that many people could use solid fuels, firewood, coal, dung cake, and all those things. I'm going to show you the picture. And that causes huge amount of black carbon. And then you have manufacturing of brakes. They use old technologies, old brick kilns, and that causes about 200,000 brick kilns out there in India. That causes huge amount of. Some part of pollution is coming from the automobiles part, and it ranges from 7% to 14% of total black carbon pollution. Even though we say that in India there's a huge amount of pollution coming from these automobiles, but really it is not as much as when you compare with residential and the manufacturing, particularly the brick kilns. And then you have crop burning. Huge amount of crop burning that happens, particularly during the fall time. They burn huge amount of crop, and if you go to Delhi this time, you probably won't be able to breathe. It's as bad as that planes cannot land during this time. So our focus at this time is cleaner this residential portion. How do we remove? Because that is the highest portion, and that's where we are focusing. That how we can stop black carbon pollution from the residential cooking. In other words, we want to provide cleaner cooked stoves to the families, poor families who are in need. And the other part, for brick kilns, we need regulations, incentives to change the brick kilns to adopt more cleaner technologies. That is happening, and incentive in this for diesel and automobiles that we need to provide incentives. That's not for current focus at this time, but the cleaner cook stoves. Let me show you that how 600 to 700 million Indians cook in India. It's about 150 million households that use, and you can see how that can add to huge amount of black carbons and carbon soot in the country. Just not only black carbons, it causes huge pollution. About 1 million people die every year from this indoor pollution, from this cooking that is used. In addition, our family generates 2 to 3 tons of CO2 from this cooking method. So if you think about 150 million households, that means 2 to 3 tons per family, per household. That's 300 to 400 million tons of carbon dioxide. That is 12 to 18% of India's carbon dioxide emission. And that can be easily solved if we provide some cleaner cook stoves, and they are available in the market. You don't have to change your lifestyle. You can use the same fuels, solid fuels that you are using, but this can stop the black carbon emission by a large amount. The problem here is the lack of awareness. The people really do not know a whole lot about the situation, the problems associated with this pollution. Also, availability of, they do not know this such stoves are available in the market. So that's the lack of awareness. Another problem is that there has been effort to adopt clean cooking methods. For example, the government of India provided cooking gas. The first one was free. The first cylinder was free. The problem with that is that they are not used to, they do not have the money to pay for this cooking gas. It's a lot more expensive. They are not used to cooking that way. It doesn't fit their lifestyle, doesn't fit their economy, the budget. And the third part is that buying the stove is very expensive. Not too expensive. It's probably $100, less than $100. But for them, $50 to $100 is a huge amount of money to invest at the front, unless they understand the benefit. So the solution was that major campaign, awareness campaign. That's what we need to do. Understand the problem, let them understand the problem and the benefits. In fact, there are plenty of benefits, in financial benefits involved in adopting these cooking stoves, which is much more energy efficient. So it reduces your solid fuels, the cost of solid fuels. It reduces the cost associated with the health problem, and it cooks much faster. A study done in Wharton School by a professor in Wharton School in Kenya, I think, or Nigeria, and with 1,000 families, and showed that the savings they make just from the fuel, within 7 to 8 months, they can pay off the initial investment. That means buying the cook stove. So the challenge here is that how do we give them a microcredit that they can adopt it, financially afford it, and probably incentives or subsidies for the manufacturers to sell it at a lower cost. And that's what we are working on. Massive awareness campaign and trying to find a way to provide this subsidy for them to adopt this cooking stove. Now, the final part is that how can you help? Now, we need a lot of people in this campaign. Technology, the products are out there in the market. The main challenge is adoption. And part of the challenge is creating awareness of this problem. That this current chula, the traditional chula that is being used, is not only causing health problems, but also causing serious damages to glaciers and climate and pollution. And the benefits of clean stoves. You can tell your friends, family, and ask them to tell another 5-10 people in cities. We can create that awareness. You can join hands. We are enlisting a lot of volunteers in those areas to make campaigns. If you're interested, you can send email to Chandan Bhattacharya, and you have the email address, and I will put that in the chat. Chandan, if you can put your email in the chat, that'd be great. And you can also use your social media to increase awareness. And that ends my talk. Over to you, Shreyans. And if you have any questions, I'm happy to answer.
That was really wonderful. Thank you, Soumitra, for that great presentation. I think there is a question we already have at this point, and I would encourage everyone to ask as many questions as you can for, let's say, the next 10 minutes. The question is from Vijayadas Gosal, and he's asking if traditional stove, which is low cost, like, can you approximate the solution? Okay, so he's saying question is whether traditional stove, which is low cost, can approximate the solution. I'm not sure if I get that question right, but Soumitra, if you have any insights,
It's possible. I mean, it's not a big problem, but so let us go back to this. If you're talking about this kind of chula, how do we contain the black smoke from this? This kind of situation will be very hard to do that. Let me show you some of the, one of the stove that is really interesting. I found it interesting. And it is in Sundarban area. So they use this stove instead of the other one you have seen. The benefit here, they used to cook using mango firewood. So you can use the mango firewood here. The benefit here, this turns into charcoal, and they are selling this charcoal in the market. So not only they are getting the benefits of faster cooking, savings on the firewood, but also they're able to sell some products after the burning. That is also available. So to answer your question, DJ, is that yes, it is possible. I do not doubt that. In one way or the other, we have to adopt energy efficient and a cook stove that stops the black carbon smokes. That's the idea. And there should be a lot of technological effort. And I heard UN has declared about $500 million on this effort to create new technology. Absolutely, if you find a way to use the traditional stove and contain the black carbon, that would be even better. Thank you for the question, Vijay.
Soumitra, there is another question, this time from Peter Fikowski. And Peter here is saying to Soumitra and modelers, can we recover from the existing carbon on the glaciers? It appears at first glance to be hopeless. If not, why not?
So the current, we cannot really take the recent carbon. What we can see that the snow that will be, it will be covered by the snow. So one season, next season, I'm expecting that there will be snow and the snow will be covered by that. The challenge here is that it's a continuous process. So so here is the situation that we are thinking about. Once we have the snow clean, what do you call that, white glacier, and it is melting, and maybe there will be some black carbon. We can use, for example, increase the albedo using the silica sand, that Leclerc's technology. We can increase the albedo using that. Challenge here is that once you put those silica sand to increase the albedo, there will be more carbon filling on top of that. You need to stop the source before, or even at any time, when you use the albedo, some sort of technology to increase the albedo of the glaciers. So you have to cut it short. Absolutely, you cannot take it out, but you can increase the albedo by, silica sand or other, artificial agents.
Right, right. Yeah, there is one more question, Soumitra, from Fred. And Fred is asking, do the families realize that they will need less fuel? This may be more important than other benefits.
I think some of them do, most of them they don't. I think this is and as you correctly pointed out, that is the most important benefits for them financially, because it saves them a lot of money. In fact, the study showed 300% IRR on the investment. It's a huge amount of money that they can save. Part of our job is to get that messages to the families. And we're talking about a large amount of population. We're talking about 150 million families here with their own customs and cultures. It is the difficult part, and where the women suffered the most, and women are most meek. They do not speak up. Particularly in the northern part of India, a study we have found the southern part of India, women speak up, so there is more adoption in that area. But women in the northern part of India do not speak up, and they suffered the most. So there are some cultural challenges also involved in this. And part of this thing is to educate the people, understand the issues and the benefits. But that's definitely the key question. Thank you. I think we should move on to the next. We are getting time, and we'd like to hear from Subarna, and we can ask, get back to the questions later. And she may have a lot of, interesting thoughts that we'd like to hear from her. Thank you.
Thank you, Soumitra. Subarna, please.
Let me take off the end.
All right.
Subarna, I make you co-host.
Let me share my screen and okay. Are you able to see my screen?
Not yet. No, I can't. Soumitra, can you see her screen?
Okay.
Cannot see it.
Hang on. Okay. I have given Zoom permission. How about now? Can you see that? Anything that you see on my screen?
No.
Oh, okay. Maybe, Detlina, I would ask you to share the screen, please. I don't know why my screen is not working for sharing. I'm working through a brand new computer and it is still, doing its tricks.
Okay.
So, thank you so much.
Let me share then.
Yeah. While Detlina shares, let me just start the, thank you so much, yeah. Start the conversation. Hi, everyone. Good morning, good afternoon, good evening, depending on where you are. Thank you for joining this very important conversation. And thanks to Dr. Soumitra Das for inviting me and Dr. Detlina Ivanova, Team Climformatics, for this seminar. Let's start with the topic.
I just wanted to check, do you see now my screen?
Yeah, I can.
Yes.
On my end, it's, yeah.
All right. Sorry.
Yes.
Thank you, Detlina. So yeah, let's get right to the topic. And I'm so impressed by, Soumitra, your talk. It's so important to manage the black carbon, without which we cannot proceed, I feel. But let's see how we as climate modeling and climate scientists can put together an effort to see how we can preserve the Himalayan glaciers from melting. So the picture on the screen that you see is taken from the Injaso, a glacial lake in the Mount Everest region. And this lake did not exist on trekking maps 30 years ago. In 2019, this lake, the small strip of water body that you see surrounded in the snow in the valley, so that one basically was 2 kilometers long, and the temperature still continues to rise. Thanks to Kunda Dixit of Nepali Times for this picture and the news coverage. So that tells us that as we speak, the glaciers are melting into melt ponds, lakes, and so on. Why do we even need to save Himalayan glaciers? A lot part of that has been covered by Soumitra, but I just wanted to give a rough sense that there are about 15,000 glaciers, which are like frozen reservoirs in the Himalayas. And the meltwaters from them feed 19 major rivers like Indus, Brahmaputra, and Ganga. They are some of the largest river systems that we have in India. And that has what supported the entire, food growing, food security, and the sustainability of the civilization for ages in India. So they're the major sources for fresh water, sustaining a population of 3 billion people and more. And the glaciers play an incredibly important role in feeding these rivers. But climate change is affecting the Himalayan glaciers with serious near and long-term implications, as we are seeing, as they are melting faster. And one of the main drivers of that is the pollution. The polluted air over Asia is changing climate patterns in remote Himalayan ranges. And we'll soon talk about what is being described as if it's driving Himalayas heat pump. Next slide, please. Okay. All right, I am able to change. Thank you. We see that the atmospheric drivers of the changes in the Himalayan cryospheres are surface temperature, rainfall, snowfall, atmospheric humidity, incoming shortwave and outgoing longwave radiation, near surface wind speed and direction, and combusted carbon and dense air pollution. Not all of them are anthropogenic, like you do have dust, desert sands, and so on, but black carbon soot is definitely burning fossil fuel and anthropogenic sources. Now, what are the observed impacts of the warming that we are seeing in the glaciers? So the climate change is driving the decline in low elevation snow cover and the glaciers in recent decades. A report from IPCC AR6, which is the latest report in chapter 2, says that it is warming by about 0.7 degrees per decade over the period 1980 to 2020, which was otherwise about 0.1 degree per decade over the century. Now, that is the kind of, faster warming that we are in now. And all of this is resulting in changes in the amount and seasonality of the runoff in snow-dominated and glacier-fed river basins. It has altered the frequency, magnitude, and location of most of the related natural hazards. And also it is affecting the flora and fauna in the high mountain ecosystem. And all of that is together affecting agriculture, hydropower, water quality, food security at large, on one hand. And on the other hand, it is exposing people in infrastructure and civilization to increased amount of hazards due to growing population, tourism, and socioeconomic development. So let's understand a bit about what is known as the Himalayas elevated heat pump. We already heard from Dr. Soumitra about the black carbon soot particles and how that kind of pollution is affecting Himalayan glaciers. So these carbon soot are precipitating directly onto the glacier surfaces, and also they're causing overall atmospheric warming in the region. Now, when the soot falls at the head of the glacier where you have a lot of ice, chances are that will get buried and covered in the layers of ice and would not affect the interactions to the air and the warming so much. But however, if the soot falls onto the lower reaches of a glacier, which is the glacier tongue as such, those particles are often going to remain on the surface, making the surface less reflective. It will allow for more solar radiation and melts. So soot that remains in the atmosphere also absorbs solar radiation. So now there's two-way processes. One, you have the soot on the top of the glacier where the glacier is having thinner ice, and so it is trapping radiation and warming it and melting it. And there is soot hanging in the air, and that is increasing the warming in the atmosphere. So these two facts together is propagating what is called a elevated heat pump. Now, this heat pump may be blowing large amounts of monsoon moisture farther north than would have been otherwise the case, which in turn may cause additional runaway atmospheric heating beyond the usual greenhouse effect. And that can possibly accelerate the melting of glaciers in the eastern Himalayas, particularly around the Gangotri and the other glaciers in the eastern part, more compared to those in the northwestern part of Himalayas. So recent research shows that the effects of these elevated heat pump may be changing both regional air temperature and monsoon precipitation patterns over the range. So we may have increased atmospheric heating, which is causing the many glaciers to melt along the southeastern end of the range where you have the Gangotri Glacier. But the increased moisture caused by the heat pump is being blown over to the northwest, where it falls as snow on the high elevations, and possibly this aids the growth of glaciers in that region. An example of that is the Baltoro Glacier. This is a recent research from Jeffrey Cargill, University of Arizona. So what are we seeing on the IPCC assessments of the AR6 on the Himalayas, on the changes that's happening on the glaciers? So we see in this map the locations of D and E, which is the Hindu Kush, Karakoram, and the Himalayas, respectively. And the plots on the right side, if you look at the plot for the Himalayas, the three boxes are for the winter snow water equivalent change percentage, winter air temperature in degrees centigrade, and summer air temperature change in degrees centigrade. And the red lines correspond to the RCP 8.5 cases for the 2080 to 2099 period, and the pink lines, the lighter pink lines, correspond to the 2031 to 2050 time period for the RCP 8.5. I mean, we are all aware of the fact that these RCP conditions are basically scenarios of emission, drastic changes in emission scenarios that we consider. And this particular one is, in my opinion, one of the worst assumptions, like fast proceeding emission scenarios with high impact, which is where we are leading if we are not going to curb pollution. So with that, we see that for the lower level of elevation, about 2,500 meters above sea level, there's a loss in winter snow percentage between 30 to 70%. A rise in winter temperatures is about 1 to 5 degrees, and rise in summer temperatures is about 1 to 3 degrees. Whereas in the higher elevation, 5,000 meters and above, you have the loss in winter snow 5 to 20%, rise in temperature 2 to 4 degrees in winter, and in summer 2 to 4 degrees as well. Now, it is not only one kind of problem that the Himalayan glaciers are melting, but it is also adding that a whole lot of those fresh water flowing down into the sea is also adding to the sea level rise. And that's what this report is showing, that about 10% of the sea level rise may be attributed due to melting of the Himalayan glaciers with the RCP 8.5 scenario evaluation. And the way this set of analytics is done is that the evolution of the glacier mass in 2015 to 2100 over that period is measured relative to each region's glacier mass in 2015, which is pretty recent, recent time comparison. And it shows that at the worst RCP scenario, we are close to about 10%, contributing about 10% sea level rise due to the melting of the Himalayan glaciers. We'll come back to this discussion at our conclusion as to what we think could be a way ahead. But shifting gears now to say that with all these changes happening, what can we do? Is there something that we can do? And the rest of our discussion in this context would be to show some examples from the modeling work and analytics that we have done for the Arctic sea ice impact assessment, and to see how that affects the Himalayas, how that affects the global climate, and is there something we can do similar and apply to India as well. So artificially increasing albedo of Arctic sea ice using Arctic ice projects, Dr. Leslie Field's technology for highly reflective hollow glass microspheres in Bhattacharyya, spreading them Arctic sea ice widely over all of Arctic sea ice, and also over smaller regions of Fram Strait. We designed and ran sensitivity experiments using fully coupled climate models, CESM1 and CSM2. And our modeling shows that restoring sea ice in Bhattacharyya changes tropical monsoon rainfall, particularly over the monsoon season in India, which is June, July, August. And you see on the left side is the test case, which is the RCP. We have worked with RCP 4.6 scenario, which is slightly less aggressive than the 8.5. And even with that, the left side versus the right side, which is the test case versus control, we see that the difference between them, which is in the bottom left corner, you have reduction in the rainfall in one part and increase in rainfall in the other. And some of that is significant statistically at 95% confidence. We have similar results from the modeling for Arctic wide width, which is the case where we intervene with this AIP technology across all the Arctic sea ice. And we also applied to smaller strategic area on the Fram Strait. And here are the two cases from June, July, August in the tropical rainfall. And we see that there is a similar pattern we are noticing with reduction of the rainfall in the central part and increase in the northern part. And there is some pockets where the results are significant, not too much. And in the Fram case, we have a similar result as well. Overall, I mean, there are minute differences between areas and pockets of rainfall. But this is just to illustrate and as a segue to our main discussion of what is the technology about, what we can do about it. And I hand over and I request Dr. Deadlina Ivanova to speak a bit about these technologies, and then we come back and reassess where we are and what we can do.
All right, thank you, Subarna. Thank you, everyone. So I will be quick. We don't have enough time to probably share all the results I wanted to show with you for Arctic restoration, climate restoration. We're working with Arctic Ice Project to vet their technology, which they're proposing for restoring the sea ice in Arctic. So what they're using, those are non-toxic hollow glass microspheres. This is a zoom-in image with the size of about 60 microns, and they look like the quartz white sand on the Tampa Bay beaches. But here you can see there are small scale field tests, and part of this little pond is covered with the AGMs, the Arctic IIP materials. And you can see how much brighter they turn the sea ice in this pond. So generally the field tests show about 20 to 30% increase in the albedo and about 50% increase in the sea ice thickness. So what we are doing at Climformatics, we are vetting the climate restoration technologies by using modeling and evaluating the impacts from those applications. Here we're showing artificial enhancement of the sea ice albedo over the entire Arctic basin. To the left, you can see a snapshot of September projection of a control case where the sea ice albedo has not been treated. And you can see how reduced is this sea ice area. The coverage is less than half of the 80s September minimums. And then treating the sea ice albedo, we can increase this September extent much to the previous state of climate. But furthermore, I wanted to show some key results of the studies. So this is the study where we're applying Arctic light albedo perturbation. And this is the results we're getting for the changes in the radiation balance. These are the differences of the fields of the global treatment and the control cases. So you're looking here at increases in red and decreases in blue. So we can see that by changing the sea ice albedo with about 12 to 15% in some regional areas, we can decrease the solar radiation, which is absorbed by the surface, with about 10 to 25 watts per meter square in some cases. And we also decreasing the outgoing radiation at the top of the atmosphere with about 4 to 10 watts per meter square, which implies that we are cooling the atmosphere over the Arctic with this type of technology. Here we're showing another case study with treatment of the albedo in a small region over the Fram Strait. So why we're choosing this region? The Fram Strait is a major gateway of sea ice export. So generally, by natural processes, the sea ice is exported through Fram Strait in the North Atlantic where it melts. So by increasing the sea ice albedo in this area, we're going to thicken the sea ice, strengthen it, and slow down the sea ice export. So that was our choice for this region. What we noticed in our results, here I'm showing the key results of the study, that changing the sea ice albedo not only changes the radiation balance in this particular region, but it also is triggering changes in the atmospheric circulation. This is the first plot here, which I'm pointing to. These are the differences in the sea level pressure and the surface winds between the from case treatment and the control case. And you can see that it's not only the from sea ice export slowing down in the terms that the circulation is changing towards the central Arctic. So these winds will trigger sea ice drift to drift in the central Arctic. And that means that we're not going to lose ice, but we will have the potential to accumulate ice in the central Arctic areas. Here and to the right, I'm showing the changes in the sea ice thickness. So the increased ice albedo and thickness in the Fram Strait not only changes locally in the treatment region, the sea ice thickness, but also is potentially recovering sea ice, multi-year sea ice in the central Arctic basin. And here I'm showing our latest study results where we simulated intervention in the Bhattacharyya. Bhattacharyya is a major large-scale feature of the large-scale sea ice circulation. Here the region is outlined in the magenta. We picked this location in Beaufort Sea because it's close to the coast of Alaska, and it will be practical for deployment, but it also is very important to use the dynamics of the Bhattacharyya, which will spread the IIP material beyond the treatment region. Here I'm showing the perturbation in different seasons. The strongest effect of the albedo is during the daylight area. And we can see that the perturbation is about 40 to 50% albedo increase during the summer period, and about 20 to 30 during the October, the late fall. And it's not only limited to the treatment region, but also we can see it spreads, as we were suggesting, it's going to spread through the dynamics of the Bhattacharyya in the rest of the basin. Here I'm showing the increase of the sea ice thickness because of this treatment, and we can see that we have thickening of the sea ice through the entire year, with maximum thickening during the summer where it's more than 1 meter. It just shows a promising potential for recovering the multi-year and thick sea ice in the Arctic. Here I'm showing the sea ice area animation. We can see if you look into the different months, these are monthly fields, that during the summer we have much larger sea ice area coverage. So there is a potential of recovering the September sea ice minimum area in the Arctic. And I want to finish with this important result. We have here a total accumulated sea ice Arctic area compared to the control case and the treatment case. The treatment is in the blue curve and the red is the control case. So we are having a future scenario with 4.5. And if you can see in the treatment case, the sea ice area in September is less than 1 million square kilometer, which defines the Arctic free ice in about 2026. So it's very soon. In the treated case, this disappearance is delayed with 25 years. So one important thing in conclusion here is that the solution which we are suggesting by increasing the albedo to thicken and increase the sea ice cover, it's not going to help though to stop the melting. if we do not apply the main mitigation measures for reducing the greenhouse gases, our proposed solutions is not gonna help on their own. We have to do everything together in order to delay the decline and stop and reverse the climate change effects. And I will take it over to Subarna. This is another result showing that by reducing the albedo, we decreasing the warming of the Arctic. We're still working on the rest of the results to see the impacts to the other area of the world from this work. Thank you. And I'm taking, Subarna, it's back to you to finish.
Thank you, Deslina. So with all of that, it seems that there is hope. And here we have made the brave attempt to put a set of things together to think how we can attempt to solve this problem. So here's our proposal for restoring the Himalayan glaciers. Of course, first we have to do the measures for drastic pollution emission reduction, which is what Dr. Soumitra Das talked about, and we cannot emphasize the importance of that enough. That has to be done. Now, there would be different ways of doing that. There in this august body of audience, I know there's Peter Wadhams, there's Peter Fikowski. Hi to both of you. I think reduction in pollution from a policy perspective, from an implementation perspective, direct carbon capture, innovating with the cook stoves. The answer here is we will need all of that in some or other way. That's the first step. Then we can, once that is ensured, then we can come to the next step of artificial albedo enhancement using Dr. Leslie Field's and AIP's HEM technology of the white silica sand. And we can implement that on the thinning and melting ice of the Himalayan glaciers to increase the albedo and alter the localized radiation balance to impact or encourage the growth of the glaciers back. But those are the top two. But along with that, we have a tremendous amount of population in the northern Indian belt, and a lot of that is creating urban heat islands in the cities. They're congested and they're, it's like forests made out of bricks and infrastructures instead of trees. So those urban and land heat management has to be done. And there are different ways of doing that, but we don't want to get into the details, but a lot of the cities and, governments are already making those changes to assess and improve on their urban heat management. Now, together with that comes the question of flood mitigation and coastal sea level rise mitigation. Now, recently, I myself, my original city I come from is Kolkata, Calcutta, and I am seeing that Calcutta, West Bengal, Orissa, they are getting an enormous amount of storms back to back, and it is causing flooding even in the cities, and it is affecting the Sundarban areas. One of the reasons that we think this is happening is because of the warming, because of the pollution, the big Himalayan rivers, Ganga, Brahmaputra, they're among the big Himalayan rivers, particularly flowing into the delta, Sundarban Delta area. Now, that's an enormous amount of fresh water that is flowing through West Bengal and Bangladesh. Part of it is through Orissa too, when big rivers like Mahanadi come and empty as well. But the sheer amount of fresh water getting into the delta region is high. And that together with the fact that when the water is coming down, flowing down the mountain from the Himalayan slopes, they are bringing with them, bits and pieces of the soil, the rocks, the debris, all of that coming down with the waters and gradually getting deposited as the water slows down towards the delta. They get deposited and they raise the riverbed and the seabed at the delta. And that is also causing or contributing to the localized sea level rise that is happening there. And maybe a combination of all of that is actually leading to the flooding that we are seeing, particularly in Kolkata, which has increased in the recent years. So all of that can be handled if we can manage the source of the problem, which is the melting of the glaciers. So if we can slow that down and, less amount of water flows into the delta, that's one solution. But that is not all, because that is going to take time. So along with that, there may be a way to manage this excess amount of fresh water. Fresh water is very precious. The world is running out of fresh water. So we don't want all of that to simply go and unload it into the sea where we cannot use them. So if there is a way we can contain that water through interconnected river systems, canal systems, and bring that water to the less dry, or let's say less drier part, the arid parts of India, which is the central India and the southern India through the Deccan, if we can channelize that water, maybe that can save the flooding and the immediate distress that is causing to the people residing in those places. I believe that a combination of all of these factors, if they can be approached in an integrated manner, may provide a path towards an integrated solution. And we as Climformatics team, as climate modelers, scientists, engineers, and risk assessors, we are happy to sit together, brainstorm, come up with, vetting the possibility and the feasibility of each and every of these factors in modeling. And therefore, even before we implement, we can have a blueprint as to how the solution would look. Where are we headed? With that, I thank you very much for this opportunity, and we can answer any questions. Thank you.
Thank you so much, Subarna. There are lots of questions at the moment, and I really at this point, so Leslie, Fred, Raj, I have all your questions. I just would like to pick up Peter's question first, real quick. And if Soumitra, if you're here, you can answer this question. And Peter essentially is saying, it appears that the immediate requirement is to reduce family size and population. Bangladesh population has more than doubled. Wait, where did this question go? The chat unfortunately closed on my end, but I mean, Peter was essentially implying that population is definitely a huge, okay, yeah. So Bangladesh population has more than doubled since Muhammad Yunus started microfinance and helped reduce average family size from 5 to 2. We need to continue that to an average family size of 1 to 2. Would you agree that nothing else will eliminate immense human suffering in the countries? Soumitra, if you are here, please feel free to answer that question.
Thank you, Shreyans. Thank you, Peter, for the questions. Population increase and this climate problem often has been shown they are extremely correlated, very correlated, and I have seen many graphs on that. I'm not very sure. One of the things that we learned in the statistics, that correlation is not the causation. The cause is not the population growth that is causing the climate change. The reason it is causing is because the population using fossil fuels. That is the spurious variable that we often miss in the correlation. Just give an example, the US is much smaller country in terms of population than India. But in India, we have about 2.5 billion billion tons of CO2 emissions compared to probably 7 or 8 billion emissions in the US. So 1/3 of the population, so 1.3 billion population in India versus about 300 million population in the US. But when you see that amount of CO2 emitted, it's much, much higher, 3 times higher than India. So it's not, I'm not saying that population is not beneficial, control is beneficial because of the limited resources that we have on Earth. We need to do that, but we need to understand the population has its own dynamics. We have tried in many places with really bad effects. In India, we tried population control in 1970s. China tried that. It has its own population dividend problem, lot of other issues. Also, you have to understand how the population grows. There's been lots of studies of the population dynamics. That the agricultural community has its own reasons to have increased population because of the number of people to asset to them. And also death rate is very, very high for them. For the industrial community, the cost, the economics makes the family size smaller because it's very expensive for us to grow the children. As the country moves from the agriculture to industrial population direction, we see the automatic decrease of the population happens. It's happened in India last 20, 30 years. It's going to happen, it's happening. By any other means, you cannot change the population. I wish we could do that. And it takes years, 30, 40 years to change, or even more, to change that happen, unless you take a draconian step to do that. So just to summarize, we have a very immediate problem in hand. We need immediate intervention. And we have certain solutions to reduce the emission of black carbon. We have solution to improve the albedo of the glaciers. Let us intervene those things immediately. And then the long-term solution is to remove carbon dioxide from the atmosphere, bring it the temperature to the point where the humanity can flourish or has been flourishing for the millions of years. We need to get to that point. But it takes that long-term planning. It takes a long, long time. Maybe, not in my lifetime, probably 30, 40, 50, 60 years. We may have population control or even those temperature. But the problem we have is right now, my house is burning at the moment. We need to throw water, not to make a different planning for the house. Thank you.
Thank you so much, Soumitra, for that answer. Yeah, my house is burning. Okay. This is now, there are, of course, many questions, but I would like to jump from a question more suited to Soumitra to a question more suited to Subarna here, maybe. So Subarna, Dwijedas Gosal, he is asking, while projecting the result, should we consider the positive feedback that happens because of permafrost burst releasing methane? Does the model accommodate that probability? I don't exactly get that question, but.
Thank you for that question, Dwijedas. Let me answer the question in 2 parts. The model does interactively, take care of the changes in the greenhouse emission. That is why we are on that, declining trend on the time series plot that Detlina showed, because we are using RCP 4.6 And that itself has aggressive emission scenario. And these emission scenarios are on a ramp, like it's assuming it's going to increase at a certain level as we go through the time. And in making those scenarios, there is there is a contribution from cases like if the methane burst happens, and that goes as a positive feedback. And the results that we are seeing are all because of those kind of positive feedback. And actually, we don't have enough time here to get into the details of those results very well. But our earlier work, first set of results that we showed were with a steady greenhouse forcing, assuming that, we stay at a level of 2000, year 2000's greenhouse forcing, and somehow we make this amazing pollution control and all governments comply with it and all industries comply with it. I know that's a big assumption, but if we can control our pollution level to say 2000 year 2000's greenhouse gas level, then under that constant greenhouse forcing, what in fact would be the result of such interventions is what we studied for the Arctic sea ice quite extensively. But now when we are doing this for the changing emission scenarios going by RCP 4.6 on a ramp, that's when all these positive feedback are feeding into the system, and that's why you're having that runaway warming. And that is what is being captured in these results. So in short, that answer is yes. But if you are saying that if that is explicitly modeled as part of this work, then that is not. I mean, we have not yet assumed that there is a large amount of methane emission as an extra additional source in the Arctic, which is happening. No, that is not included. And for your second question, I'm reading that in your chat. Are you using machine learning for analysis and other UAV images based on? So we actually have a different part of our work where we work with, vetting climate technologies, not only by climate modeling, but also finding out what in fact would be the impact of climate restoration technologies at your location, at your zip code, at within the next few years of implementation to far ahead. And so that part of the work is where we use the machine learning. We have our own algorithms which are actually bridging the gap between the current climate model technology and bringing a predictive, accurate, let's say, climate and weather in the long term application. So yes, we are using machine learning and a lot of data, including imageries and historical data to get there. I don't know if I have been able to answer your question.
May I add to the answer? Would that be okay?
Oh, thank you so much, Leslie.
Yeah, thank you. I mean, this is fantastically, well, it's a great webinar. Thank you. In the Arctic, some of the results that Dedalina was showing, part of what's exciting to us about preserving Arctic sea ice is that we have the possibility to reduce the future methane emissions that might happen otherwise with more extensive melt. And so, as I understand it, the modeling hasn't taken that part into account yet, but it's something that's a potential big risk reducer for the world that we're pretty darn excited about. And as to the, I agree very much with the question of, are you doing machine learning? Are you imaging from above and such? I wanted to emphasize that for the small, very small field testing results that we do that help feed into the climate modeling of, what kind of albedo would we expect on the work we've been doing so far. We use a lot of instrumentation to look at what kind of albedo is really there, how much reflectivity in short wave, long wave, temperatures, ice thickness, things like that, and drone aerial footage as well. So there's, if your question was more directed towards, are we doing some ground truthing, or as we like to call it, ice truthing, that happens as well. But I could go on all day, and that is not the agenda here. So thanks very much.
Thank you, Leslie. Another
Can I
question.
actually add to that question? Because we have, I think, in this discussion, a world expert who we would like to hear some comments from, Dr. Peter Wadhams. I was just going to suggest if you could, throw some light on the methane problem. To my mind, if we are able to keep the Arctic cool, part of the methane problem is in control. But let's hear from you. Peter, are you there?
Maybe we'll
Maybe
get back.
Okay.
I've asked him to unmute. Okay. Yeah. Should we take a question before you
Sure.
unmute?
Go ahead.
Yes.
Okay. So I would like to combine a question from Peter Fikowski with a question by Leslie, of course. And honestly, Leslie's question looks more like, Leslie giving us more ideas on this, so that's great. But Peter essentially is asking Soumitra and everyone a follow-up. Soumitra said that if we cover the black carbon with silicon beads, that will allow us to stop the melt. How much would it cost to do that? We might realistically provide that. Who might realistically provide that funding? It seems that we need to answer those questions before cook stoves will make a difference for the glaciers. And Leslie essentially saying, could Kiva help publicize and fund this? Soumitra.
So this is a very important question. Thanks for asking this question, Peter. What is the cost? Who is going to fund these questions? Cook stove is a separate thing. It's already in progress. There has been a lot of, I would say, emphasis from United Nations, and they have made a huge amount of money available for cook stoves. So, and in India also, there has been some effort for giving cook stoves. In fact, I'm speaking with some investors, and because it reduces carbon dioxide, so we can get money on carbon offset. So this is something avenue I'm looking. So it could provide subsidies for the families for cook stoves. So carbon offset, one thing, we're getting money, and the money I'm hoping from the government, because there is a lot of programs on this. And most importantly, it's not really, you don't need the money here, because changing cook stove would generate enough savings for the people. And it has been shown that percentage of IRS blue, the investment of 3,000 rupees or 5,000 rupees will be recovered in a few months from the savings of the solid fuels. It has been shown over and over in different studies. So it's not really, we need that a lot of money coming. Although, we are looking into finding a way to provide subsidies, incentive to for the families. So for the cook stove, that's so keeping that cook stove aside. The other part is that who is going to provide that silicon part, how much it costs. I'll leave that to Leslie. For that, we have not really valuated the cost, and that's part of the things that we need to do. But what we understand from Leslie and Subarna's talk is that you don't need to cover the whole Himalayan glaciers. You need to have some certain strategic areas where you need to put that and cover those silica bits or hollow glass microsphere. That could solve the problem. How much that is going to cost, we do not know that yet. And that's something we need to do. And whether that strategic areas and covering the strategic areas with silica would solve the problem, we do not know that yet. So yes, we have some homework to do, and we have to do that yet. But the cook stove part, and that's why we're taking the cook stove for 100. It is something, not only the problem for Himalayas, it is the problem also for the country because of the pollution level. In Delhi today, it is probably 6 to 10 times more than the the limit of pollution the human can survive. It is damaging the lungs, causing death for lots of people. So aside from the Himalayan glacier, we have another problem with pollution in India, and Cookstove can solve part of the problem. So I hope that answered your question, Peter.
I can add if you want, Soumitra, or not.
Please go ahead.
Okay.
Absolutely,
Yeah.
because the cost part I do not have. That's something you can, give us some idea.
Yeah, depending what materials we're using, it can be, $7 to $10 a pound, if I'm recalling right. The number that sticks in my head is 350 million for 100,000 square kilometers, but we're not talking about anywhere near that big in material cost. And then, of course, there's deployment cost. But Soumitra is right. The whole trick, both for reducing environmental impact and reducing costs and reducing logistics challenges, is always trying to figure out where's the key spot. Where will you get the most benefit from the least treatment? And that's why it's so key for us to be collaborating with Subarna and Dedalina on climate modeling to see, well, where could you get the most impact with the least intervention? We're doing some pre-homework. I like that you mentioned homework with volunteers in Minnesota who are working. They're actually, thanks to another volunteer, connected with an Icelandic glaciologist who's shipping us some ash for us to give a try on a Minnesota lake. So that's a Minnesota small pond. So that's some of the homework that we're looking at. Is there are many ways that glaciers can darken. Which ways can we actually address that would be helpful? So there's as Soumitra very correctly said, there's a whole lot to do. And thank you, Peter Fiakowski, for that just absolutely key question. How much will it cost? Who will pay? That's very key in all of these.
So I want to add a little bit more to that. Leslie, thank you for your, odds are definitely, we have to do the work, but we have certain ideas on this. And we need really collaborators. We need help from everyone on this project. It's not, 2 people person job or, few organizations job. It's a huge task we have undertaken because the cost of not doing is enormous. It is going to destabilize the whole world. So it is the responsibility of the whole world to save that part. Now, in terms of who is going to bear the cost, I'm hoping that government of India, China, and the countries, we do have a intergovernmental organization called ICIMOD, which consists of 8 countries that are watching Himalayas. I'm hoping that those 8 countries that come forward, and in fact, even UN to come forward to help us on the cost. In terms of our plan, that with Arctic Ice Project, Climate Reality, the Climate Reality Project, India, Climformatics, what we plan to do is to show that this technology works. We want to do it on a pilot. That's not going to cost a huge amount of money. That's I'm thinking about within $500,000 that can be done. We want to show the work, this work, and then I'm hoping that the governments, that going to be affected, and not only the government, but the world is going to be affected by this, is going to undertake this thing because cost of not doing, and I want to repeat this, cost of not doing is enormous. And the cost for doing is not as much compared to the cost of not doing it. Thank you.
Thank you so much, Soumitra. So I tried asking Professor Wadhams to unmute, but it seems he's not here. Okay. In that case, we have Paul Anderson, who has been raising his hand for quite a while now. So if you'd want to add something, Paul, feel free to do so.
Yes, thank you. It's been a wonderful webinar. I wasn't expecting as much emphasis on the cook stoves. I'm delighted with that. One of the cook stoves shown in the slides, I created it, and I can speak at great length about the champion stove, the one in the Sundarbans. I'm looking for, I put my contact information into the chat. I want to talk with the specific people about it. I will disagree about the issue that these people can afford it. You're asking the very poorest people of the world to make a sacrifice that should also be of benefit to the wealthiest. And if we can't just lend the money for that, the money will be paid back. So if you happen to know anybody who's really, really wealthy, we will make them famous for saving the world just by moving that forward. So that stuff is in my white paper on climate intervention. And I put up the website on it, section 12. Now, I do want to talk with you people about it, please. And I have been into Calcutta and I have a contact there, Mr. Molindu Banerjee will make the contacts. The question I want to address is with regard to the Arctic. Is it not possible, it is possible, I know it's possible, to build ice on top of the ocean, and especially in the wintertime? They do it when they build the ice highways, which they're used to go through the Arctic, and they build it thick enough that it's able to support major trucks and everything. Why not extend that out from the coast of Alaska and Canada out into there? It's a short pump. I mean, you're going from seawater level to above seawater level. You're only maybe raising it 2 or 3 feet, but you're raising it out and it creates a layer of ice on top of the ice. It is separated naturally by the freshwater part freezes. The brine goes back into the ocean. You build up an ice bridge and move it on out. And what I learned here today was about this Jiri and the circulation. You would actually want it to be swept away from the coastal areas where we can service it better, to be able to run these pumps. Pumps you can't run with solar in the height of the Arctic winter, but otherwise you can get a lot of stuff done. So has anything been done about building ice as is done with ice highways?
I will say that what we look at is taking advantage of the fact that ice still forms in the winter. It's just young ice, very thin, not very reflective, and so we brighten it with this, thing that looks like hollow, like floating white sand. So that's one way to try to leverage things and make them last longer. And those are the modeling results you've seen. But Peter Wadhams, you're here, and you were speaking yesterday, I think, about including such things as ice roads and whether you thought those, that technology worked, right? Pumping water back up.
Well, in my personal view, it's not going to be scalable up to be an adequate method Arctic wide. And I showed a slide of a 3-part way of trying to bring back Arctic sea ice, but it's not a slide I particularly agreed with on the question of restoring the ice and directly by pumping water. I mean, I've seen tons of stuff about this, and I simply really can't bring myself to believe it by looking at the numbers. And we've just heard about pumping water over ice to increase the growth of the ice. The amount of energy needed to do that is enormous, and the ability to be able to increase ice thickness and ice area by doing that, I believe is not a viable way forward. I'd be happy to be proved wrong.
Has anybody attempted it, and with the numbers from the ice highway types of things? The cost of putting all those little bubbles on is certainly not a trivial matter either.
Oh no, that's a different thing. I mean, changing the albedo by adding material to the surface, as Leslie's proposing, that's trying to preserve ice through keeping a high albedo. That's something that I think does have a future. But actually pumping water onto ice and freezing it, the amount of energy required is just too great. I mean, it has been tried, but on a much smaller scale, because it's a technique that's been used by the oil industry to thicken ice flows in order to use them as the basis for drilling rigs, make the ice thicker so it grounds on the seabed, and then you put a drilling rig on it. But you can do that with an ice flow that's a kilometre across or something. But we're dealing with millions of square kilometres here, and if you look at the numbers for trying to do something on that scale, it becomes pretty horrendous.
Thank you, Professor Wadhams. I know Dr. Mahendra Bhutiani is also here, so I think we just take a question from him, or like whatever he wants to say.
Dr. Bhutiani, you're on mute. You need to unmute yourself.
Okay. Now?
Yes, please.
I just wanted to ask the presenter that how did she think that interlinking of rivers in the north with the rivers in the south will solve the problem of flooding in the northern region? Basically, that project of interlinking of rivers has been a non-starter. It is a capital intensive, and with the different geological settings in Peninsular India and Indo-Gangetic Plains, I think we should not even speak of that aspect. Maybe interlinking of rivers at local, maybe at few places it may be feasible, but overall it's a non-starter. Only idea I think we should re-emphasize in this particular forum is to have our regular glaciers acting as regulators of discharge. They used to do this job earlier, basically, but in the scenario of climate change with warming scenarios, the glaciers are no longer acting as regulators of discharge in the rivers, basically in the glaciarized regions of the Himalayas. So I think idea is to basically restore the glaciers that we have in the higher reaches. I think linking of rivers in the Indo-Gangetic Plains and the Peninsular India may not be a feasible idea. I think we should not even discuss it at this stage. That's what I wanted to add.
Thank you so much for your comment, Dr. Bhutiani. I graciously accept that idea, but my question is, I was thinking, brainstorming with myself and my colleagues, that this excess amount of fresh water that is going into the sea, how can we use that and in a way that kind of, solves particularly for coastal regions like Calcutta, maybe the same for Bangladesh. How can we use that fresh water or, maneuver it somewhere where it doesn't cause the sea level coastal rise or the flooding in the coastal cities?
It's interesting because there are obviously both aspects to this. They're already trying to a river linking project in central India between Ken and Betwa rivers, but that has had conversations on both sides. I think that Lena wants to talk about something real quick. She has her hand.
Yeah, thank you. Well, I just wanted to invite everyone, participant and attending this seminar. If you wish to publish topic on issues and solutions for Himalayan, Arctic, and Greenland sea ice, I'm kind of organizing a special issue in the journal Frontiers. It's a new journal. Which is with a topic on problems and solutions for the sea ice in Arctic and the land ice in Greenland and Himalayan. So please, I sent my email in the chat if you are interested, and if you are also interested to work on topics with our modeling studies and our modeling simulations, which we have in all of this area. We have global coverage, so we can work together on any issues you're interested as well. So that's from me. But yeah, send me an email if you're interested. let's discuss a paper or work together. Thank you.
Thank you so much, Adelina. Subarna and Soumitra, we have started running out of time now. Do you guys feel we should move towards closing it, or do you want one more question?
I think let us close. I wanted to do this by 11:30. It's 11:41. So, Subarna, if you have any closing remark, after that I will do that, and then we can follow up with vote of thanks. I just want one question. Maybe Fred Leet has. Fred has put up his hand for a while, so let us give him a chance to say a few words.
Okay. I just wanted to point out that the Himalayan situation is different from the Arctic in that the black soot is going to be most prevalent in dried up river channels and moraines, whereas on the Arctic, you have to form ice everywhere. In covering the moraines with ice and covering the channels with ice, you only have to do a relatively small amount of the glacier, as distinct from the Arctic, where you have to cover the whole thing. So it may be much more possible than Peter thinks.
Thank you.
Yeah,
Okay, go ahead, please.
I would like to respond to that comment, Fred. I think I agree with you, Fred. Also, when I was doing my studies on the Himalayas, I found that because of the terrain is also very rough, difficult, and it's hard to do credible deployment anywhere and everywhere that we choose like. But you're right, because the amount of intervention needed, if we can reach the right spot, is much lesser than what we need for the Arctic. And also because of these dynamics that's different, or at least currently the pollution has made it different between the central and southeastern parts of the Himalayan glaciers compared to the northwest. So there may be that dynamics, we might be able to part of that dynamics a little bit with these, with the AIP technology, for example, and see what that does, in a modeling framework, and see how it would be impacting, helping or hurting. And like in the Arctic example, we found that deploying in a particular strategic area like the Fram Strait, and now we are working on the Bhattacharyya, which is a larger area. But even in the Fram Strait, which was a smaller area, but it was quite impactful because we could take advantage of the basic Arctic dipole dynamics in that region. So something like that might be possible to test out, at least in the Himalayan glaciers.
Thank you, Subarna. Shreyans?
Yeah. Any more questions, Soumitra, Subarna, you guys want, or should we move over to Chandan now? Because there are a lot more questions, honestly.
I think we should stop now. Let Subarna give a chance to make a closing remark. I'll make a closing remark, 30 seconds, and then move on to Chandan for a vote of thanks.
Thank you so much, Soumitra. I think this has been such a great seminar and a brainstorming session between, what is possible, what could we do, and what would be the first steps, and how do we go about it. I think it is important to carry on this kind of conversation, more brainstorming sessions with all possible, technologies that can come together. Like today we learned, maybe the interconnecting of the rivers may not be a good idea, but maybe some other way to channelize that flooding problem, or channelize that water, or use it for power. However, whatever would help to restore the system and help the people, carry on with their lives and businesses uninterrupted, inconvenient, not not interrupted for anything. So that would be our goal. So we are happy to collaborate, happy to brainstorm and move this forward. By the way, we are actually also members of the United Nations ARISE network with public-private partnership, the Disaster Risk Resilience chapter of the UN. And we are glad to write collaborative proposals asking for funding to the UN bodies and the private networks as well. Thank you.
I also wanted to add to the Subarna's remarks, why not use this excessive glacier meltwater, which is right now disposed in the ocean and rising the sea level, to create new, maybe not canal systems, but new hydropower plants and switch the coal fuel and the fossil fuel energy which we are using now for the stoves with this new electricity from hydropower, the greening the electricity power you're using in Himalayas. I think if the governments or other sources can be funding such type of projects to transition to a greener electricity power production, that will be one route to go to. And you have the benefit, yes, you have now even extra river flow to produce hydropower rather than use the fossil fuels around it. So that's all I had to say.
Yeah, I think none of us here want to disconnect from this call, of course, obviously, but it's about time. So I would like to move this over to Chandan now, who can do the closing remarks. Chandan?
Yes. Chandan, we cannot see you.
Are you coming?
Go ahead.
Okay. I don't know why my picture is not coming, but it is on. Anyway, thank you everybody for presenting such a wonderful webinar. Here our speakers, Dr. Soumitra Das and Dr. Subarna Bhattacharyya, they have given a very nice presentation with their research work. And I appreciate the participants for raising so many questions, and the answers we got from the brainstorming session in the webinar is wonderful. I appreciate everybody, and I thank everybody for their wholehearted participation in the webinar. There are many participants, but I should name the few: that Peter Wadham sir, Leslie Field, Peter Fikorski, Rituraj Fukan, Paul Anderson, Mr. Bhutia, and many others. They have given their beautiful answers on the questions, and they have raised very good questions. And I hope this movement for the Himalayan melting will take up a new stage with this from this discussion, from this webinar, and in future we will conduct more webinars on this subject, and your participation will help us to move forward in this movement. So I will request everybody that you can write in my mail ID chandank1963@gmail.com who wants certificate for this attending this webinar. Thank you so much once again for your participation. Have a very nice, very good day. Namaskar.
Thank you so much, everyone, for attending. It's not a one-person job, two-person job. We need your collaboration in this project. Thank you so much.
Thank you.
Thank you.
Oh, well done. Thank you.
Thanks. Bye-bye. Bye, everyone.
Thank you. Bye.
Bye-bye. Thank you.
Take care. Bye-bye.
Thank you.
Shreyans, Dijo, or Chandan, if you can stay.
Sure.
Dijo, Chandan, Shreyans, Jointo, then we can have,
Raj quit. Raj left pretty early. I think he probably has to go to bed or something.
he had a different webinar. So we can have a meeting. Chandan dropped out, I see.
It says Chandan Kumar Bhattacharya as a participant already. I think he's probably trying to reconnect.
Yes, I'm here.
Soumitra, I just wanted to ask you, we are going to have some meeting with regard to that proposal and of course, next course of action. Is it going to be today or some other day? I mean, it has to be sort of.
I thought we would be in today, but looks like it is nobody responded, so I did not make it. I'll send in another email. And Raj has another webinar, so he won't be able to make it.
So I think let Raj coordinate it. We'll have some other time then.
Yes, we will do that.
Okay. Then I'm also leaving. Thank you so much.
Thank you.
Huh?
Thank you. Thank you. Yeah, we'll have some internal meeting with our people.
Yeah.
So that...
In fact, I was thinking of submitting the same proposal to some other organizations. Let's have some brainstorming on that. That's
okay. I think that will be a good idea. Let us talk about that next week.
Okay, next.
I will.
I'll ask Raj to organize it.
Yes, I will do that.
Okay, done.
Thank you so much for attending, Dr. Rutiani.
A wonderful webinar. In fact, it was very, very enlightening. Very, very good.
Thank you so much. Thank you.
Thank you, Dr. Rutiani.
Thank you so much. Thank you. Thank you, Shreyas. Thank you.
So I'm removing everyone else except the one from HCI, and we'll have internal meeting. Okay.
It's still recording. So whenever the recording is put up, I think I should wait. Soumitra, it seems like you have the command on stopping the recording now.
Okay, so I can